Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning class.
Good morning, Miss.
Clear? Suara saya clear? Line awak okay? Okay. Alright, so for today's lecture, we're going to continue on with a new topic, the second topic in SK025 called thermochemistry. Okay, so kalau kita tengok thermochemistry ni, Ya Allah ya Tuhan. Thermochemistry ni kalau awak tengok lah apa yang awak faham dari term thermo and chemistry? Thermochemistry kita bagi dia dua.
Reaction heat.
Okay, reaction dengan heat. Daripada chemistry kita tahu chemical reactions kan? Okay, daripada thermo kita tahu dia akan release or absorb heat lah. Okay, jadi in thermochemistry kita still rely on the chemical reactions where you have your reactant to form product, the irreversible reactions, but then we have additional feature of amount of heat release. The amount of heat release ni lah yang kita panggil dia sebagai enthalpy, yang delta H tu. Sebelum ni pernah jumpa kan simbol delta H?
Benar.
Okay, delta H tu dia punya term kita panggil sebagai enthalpy. So for today's lecture, part of our lecture today, kita akan cover dua subtopic. We are going to learn about this concept of enthalpy. Okay, so thermochemistry is basically a study of heat change in chemical reactions. Bila sebut study of heat change in chemical reactions, first kita kena tahu macam mana dia punya setup. So, in the chemical reactions, before this, you learned about the law of conservations of mass. Maksudnya SEM 1, bila kita ada reactant to become product, dihasilkan apa, dia perlukan apa tu kita just rely on law of conservations of mass. But in second semester, kita akan guna law of conservations of energy where you include energy as part of your reactions. So as part of these reactions, kita perlukan this setup. First, you need the surrounding. Kita tahu surrounding is our persekitaran. Okay, persekitaran kita macam udara semua ni. Okay, and then dalam satu sistem mestilah ada sistem. Dalam chemical reaction mesti ada sistem dia. So kita ada 3 jenis sistem yang awak kena tahu. Sistem kita ada 3 jenis. One is open. Open system means bila kita sebut tentang law of conservation of energy, we include exchange of energy. Okay, exchange of energy. Exchange of energy ni means dia dalam chemical reactions ada perubahan energi ke tidak. Bila open, dia sistem yang terbuka. Jadi energi boleh keluar masuk macam tu saja. Same goes to water vapor. Kalau awak tengok the first gambar, kita ada satu botol. Lepas tu dalam tu dia berlaku exchange of heat antara solutions dengan luar. And satu lagi yang bila dia punya bekas tu terbuka, water vapor pun boleh berlaku. Exchange of air. And then the second system yang awak akan tahu is closed system. Closed system is basically sistem yang tertutup. As compared to open system, yang berlaku dalam closed system hanyalah exchange of energy sahaja in terms of heat. And lastly is isolated system. Isolated system where there's no energy change berlaku. Dia tertutup means kalau dalam tu berlaku reaction, dalam tu sahaja dia conserve. Okay. Boleh ke faham ke 3 sistem ni? Faham. Okay, so kita akan deal, for this thermochemistry, we are going to deal with isolated system. Okay, so heat lah. Okay, so kita ada surrounding, system dan juga heat. Dia berlaku dalam satu bekas ni, kiranya surrounding tu luaran, sistem tu yang dekat dalam apa tengah berlaku, heat tu sama ada dia keluar atau masuk. Itu yang kita nak belajar dalam thermochemistry. Okay, so bila kita cakap pasal thermochemistry, kita cakap pasal concept of enthalpy, you must be familiar with this diagram, right? You know what do we call this diagram?
Energy level diagram.
Okay, energy. Dia not necessarily energy level diagram lah sebab nanti awak akan belajar energy level diagram untuk the last part of this chapter. Okay, kalau macam ni kita panggil energy profile diagram. Dia just nak tunjuk profile of reaction sebab nanti awak akan tengok yang energy level diagram tu dia a bit different, a bit complicated. Okay, so we already learned about this in chapter 1.2 regarding the collisions theory where you have reactant and product, and then you know from reactant to the transition state, the maximum potential energy, we call them as activation energy, EA, minimum energy required to initiate the reactions. And then from reactant to product, tak kisahlah from bawah to atas atau atas to bawah, exo or endo, we call them as heat release or heat absorb. So the heat release and heat absorb adalah yang kita panggil dia sebagai enthalpy, the change between reactant and product, not from reactant to the activated complex out there. Okay, so if you can see here, if you formed more product than the reactant, then your delta H gonna be positive because they are going to absorb energy. Okay, bila absorb energy ni maksudnya dia dikelilingi lah. Okay, kalau yang from reactant banyak, produk sikit, so dia akan release heat sebab dia nak try to, betul, dia nak try to lepaskan heat tu. Okay, so kita nak tengok pula dari segi dia punya equations. Before we know, for the law of conservation of mass, we just include these chemical equations. Ada reactant, ada product. But now, for law of conservation of energy, kita akan guna thermochemical equations, the same as chemical equations, but with additional feature of delta H. Boleh beza antara chemical equations dan thermochemical equations?
Can.
Boleh. Okay. So any chemical equations formed in this chapter, you are going to use these thermochemical equations only. Dah tak ada dah chemical equations sahaja. Mesti followed by thermochemical equations. Okay. So you look here. Your delta H for this example, you have negative sign. How do we know they are going to form negative or positive sign? They are all depends on the definitions of your reactions. Means we have a number of reactions. Let's say combustion. We have neutralization. Combustion kita nak bakar dengan oxygen, right?
Yes.
Ya, kalau neutralization kita tahu kita nak neutralize acid and base to form water. Okay, so positive or this negative sign rely on the definitions of your enthalpy. Okay, bila dia kata kalau combusted, apa yang kita faham? Dia akan release heat. Maksudnya heat release. Bila heat release, definition dia negative sign macam tu. Kalau kita kata kita nak atomize from solid to become gaseous atom, atomize dia require heat, so maybe dia perlukan positive sign. Kita ke yang tentukan this positive or negative? Ataupun definitions yang tentukan?
Definition.
Yes, definition. So for this subtopic, concept of enthalpy, it is very important for you to understand the definitions of each enthalpy sebab dia berubah-ubah. Okay, apart from this negative sign or positive sign, you also have this mole per mole. Okay, nampak tak? Lepas kilojoule, kilojoule is just the energy. Per mole indicates the definitions will rely on 1 mole of something that undergo the reactions. Contoh macam combustion, 1 mole of something is combusted. Sebab tu dia per mole. Jadi bukan semua reactions ada per mole. Maksudnya delta H dia. Awak kena tengok balik reactions tu betul ke the definition dengan dia punya enthalpy. Okay, yang tu yang kita nak tengok dalam satu topik ni. Dari definition kita hasilkan thermochemical equations because throughout this chapter 2.2, 2.3 and 2.4, you will need to form your own thermochemical equations. Dia bagi contoh enthalpy of combustions of something. Awak yang kena keluarkan sendiri. Tak reti keluarkan the thermochemical equations, tak boleh jawab 2.3 and 2.4. Jadi kena fokus on this, kena faham macam mana nak form the thermochemical equations. Alright, saya proceed
Okay, Miss.
Okay, macam saya cakap tadi, enthalpy of reactions, this is the example. Okay, so we are going to focus on the two things, the sign and also the magnitude. So sign we have positive and negative. Okay, here, let's say given to you delta H, these reactions, carbon react with oxygen gas to form carbon dioxide. You will have enthalpy given by the experiment is negative 22.7 kilojoule per mole. Okay, so this negative sign lah. If let's say you want the carbon and oxygen to be on the right hand side, means sekarang dia belah reactant, kita nak tukar dia jadi reactant jadi kepada produk belah kanan. Awak tengok dia kena kata kat sini, reverse reactions require a change in sign. Kalau saya letak CO2 kat belah kiri, apa yang akan terjadi pada sign awak? Negative, positive or remain the same?
Positif.
Dia akan jadi positif sebab kita terbalikkan reactions. Kenapa perlu terbalikkan reactions? Nanti bila kita buat 2.2, 2.3, 2.4, awak faham kenapa dia nak kena terbalikkan. Sebab kita kan reactions yang last sekali dia memerlukan reactions yang banyak. Jadi untuk dapatkan the targeted equation, the final one, awak kena compromise with other reactions yang berlaku. Mungkin yang ada tu kalau duduk on the same side dia akan tambah. Jadi dia tak akan dapat targeted equation. Jadi kita kena terbalikkan untuk hilangkan dia. Tu maksud dia. Kita akan tengok lagi lah contoh. Okay. Selain sign, kita akan, kalau sign ditukar macam ni lah. Selain daripada sign, kita akan tengok magnitude. So this magnitude belongs to both delta H and also your thermochemical equations, your balance equations ni. At the moment, you have 1 mole of carbon, 1 mole of O2 to form 1 mole of CO2. Okay, let's say we change the number of mole for carbon is 2. Same goes O2, same goes to CO2. What will happen? The change in stoichiometry require a change in magnitude of H. Awak ubah stoichiometry awak, same goes to your delta H dah sekarang. Tak boleh lagi biar sama 22.7. Bila darab 2, delta H pun kena darab 2. Itu faham?
Faham.
Okay, did you notice something? On the first thermochemical equations, you have negative 22.7 kilojoule per mole. While for the second thermochemical equations, once you times it with 2, you left only with this kilojoule. What happened to the per mole? Kenapa kita dah tak ada per mole sekarang?
Because we times it by 2.
Yes, because we times it by 2, jadi the definitions dah berubah. Okay, bila kita times dia dah berubah. Sebab apa? Sekejap lagi kita nak tengok the definitions ni.
Okay, Miss.
Okay, right. So, focus on this two kita akan ubah. Dia bukannya fix. Kalau dia bagi tu, itu saja tak. Kita kena ubah dia sebab nanti kita nak jawab soalan nanti perlukan perubahan. Okay. Now, we have 3 types of enthalpy change. Okay, enthalpy ni delta H awak, it can be negative. It can also be, sekejap. Dia ada negatif, dia ada positif sahaja, dia ada both positive and negative. Kalau negatif kita panggil dia heat released. Under heat release, we have 3 enthalpy involved. Kita ada enthalpy of combustions, enthalpy of neutralizations, enthalpy of hydrations. Each time you need to encounter with this enthalpy, dia akan cabut enthalpy combustions ke, neutralizations ke, hydrations. Their delta H must be in negative. Because by definitions, heat is released, not heat is absorbed. Okay?
Okay, Miss.
Alright. Okay, next one, we have heat absorbed. Under heat absorbed, we got only one type of enthalpy, which is enthalpy of atomizations. Okay, enthalpy of atomizations ni, satu ni sahaja positif. Next, we have heat change. They can be either positive or negative, depends on the information given lah. Sebab positive or this negative determined by the experiment as well. So, kita akan ada heat change ni, maksudnya dia tak fix to only negative, to only positive. Sometimes dia boleh jadi positive, sometimes dia boleh jadi negative. Enthalpy of formations, standard enthalpy of formations, and also enthalpy of solution. Okay? Sekejap, dia lambat sikit dekat awak. Saya dah patah balik. Kenapa dia tak patah balik lagi? Saya tak tahulah dia. Okay, tak apa. So sekarang dekat screen awak nampak heat release kan?
Yes, Miss.
Okay, so heat release kita akan go through one by one the definitions of each enthalpy. So for the first heat release, they involve enthalpy of combustions. Okay, enthalpy of combustions means heat released when 1 mole of substance completely combusted in oxygen gas. So from the definition, we know heat release. This heat release indicates apa dalam thermochemical equations awak. Dia bagi hint tentang apa kalau heat released.
Negative sign.
Negative
Negative.
sign. Okay, good. Okay, and then disambung. Heat release, kenapa heat release? Mesti daripada reactions. So kita tengok pula our chemical reactions. This heat release when 1 mole of a substance completely combusted in oxygen gas. Okay, so kalau awak tengok definitions, ada satu species dalam kita punya chemical equations tu yang kita perlu fixkan dia 1 mole. From these definitions, what do you think? The 1 mole belongs to the reactant or product? Kalau dia kata completely combusted in oxygen gas, dia berada pada reactant ke dah jadi produk?
Product.
Product.
Reactant lah Wak. Dia baru buat macam ni. Reactions, bila enthalpy of combustions, species dia undergo combustion to form product macam tu.
Okay, Miss.
Okay. Alright, so 1 mole of substance. Who is this substance? Depends lah reactions dengan apa. Tapi dia memerlukan oksigen untuk react. Okay, so kalau daripada contoh ni, we have carbon in solid states to react with oxygen gas in oxygen in gaseous state to form CO2 in gaseous state as well. Then you have the delta H negative 22.7 kilojoule per mole. Okay, kita tahu heat release dia bagi tahu tentang negative sign. Then 1 mole of substance completely combusted in oxygen. We know they are happening at reactant side. On your reactant side, you could see you have carbon and oxygen gas. So who do you think that you need to keep the 1 mole? Carbon or oxygen?
Carbon.
Carbon, good. So from this carbon, we know once we keep this carbon as 1 mole, that's why you have your delta H equal to negative 22.7 kilojoule per mole. 1 mole tu berpaksikan pada carbon yang kita keep sebagai 1 mole. Kita keepkan siapa yang sepatutnya 1 mole, yang lain tu sebab kita nak balance kan, nak halfkan ke, nak doublekan ke, tak ada masalah. Janji by definition siapa yang perlu 1 mole, dia perlu 1 mole. Baru boleh guna kilojoule per mole. Okay.
Okay, Miss.
Alright, kalau saya darab dengan 4 carbon, 4 O2 jadi 4 CO2. Will you still have kilojoule per mole as your unit?
No.
Why no?
Sebab dah bukan 1 mole.
Siapa yang bukan 1 mole?
Carbon.
Carbon.
Okay, carbon saja tau. Kita tengok siapa yang sepatutnya yang keep as 1 mole. Sebab itulah. Sebab sometimes dia boleh tanya awak, explain your answer. Kenapa you kata bukan lagi per mole ke and stuff. Okay. So then, the next heat release involve enthalpy of neutralizations. We know neutralizations involve reactions of acid and base to form water. So heat release now indicates the negative sign. If we look at the example, we have HCl to react with sodium hydroxide to form NaCl and water. The heat release belongs to this negative sign. And then when 1 mole of water is formed, just now from the definitions of combustions, the species that react with oxygen yang perlukan 1 mole, right?
Yes.
But now for neutralizations, do we still need to focus on the reactant side yang perlu 1 mole? No, sebab once neutralizations happen, water is formed. So the species that we need to keep as 1 mole is the water formed. Dia duduk dah produk pula. Maksudnya dia bukan semestinya reactant yang kena 1 mole. It depends by definitions. Okay? Alright. Samalah kalau kita tukar dia punya stoichiometry, let's say kan water jadi sampai 3 mole. Means yang lain pun kita kena balance lah balik kan. So kalau 3 mole, dekat delta H awak dah tak boleh guna kilojoule per mole lah. Dia tinggal kilojoule saja. Okay. Alright.
Okay.
Yeah. So the third enthalpy involved for heat release is enthalpy of hydrations. So kalau kita tengok dia punya example, heat release, your heat release belongs to the negative sign of delta H. Dan dia sambung lagi. Kenapa heat release? When 1 mole of gaseous ion is hydrated in aqueous solutions. Okay, kita tahu kita kena start dengan 1 mole of gaseous ion. That's why you have this Na+. Gaseous ion belongs to your Na+. Once they are hydrated, is hydrated means dia buat reaction dengan water lah. Cuma kita tak tunjuk lah dia tambah water. Bila dia hydrated from gaseous state, they will hydrated in aqueous solutions, they will immediately turn into aqueous states. So you could see from these thermochemical equations, you have sodium ion in gaseous state to form sodium ion in aqueous states. That's what meant by this enthalpy of hydrations. So dapatlah kilojoule per mole awak in and negative sign. Okay?
Okay, Miss.
Right. Okay, and then kita masuk kepada heat change. Tadi kita tengok heat change ada berapa enthalpy involved?
3.
3. Okay. So out of the 3, the 2 are the same. The 2 are the same means kita ada enthalpy of formations and standard enthalpy of formations. By definitions, these two membawa maksud yang sama, cuma ada sedikit perbezaan pada standard enthalpy of formations. Okay, enthalpy of formations, definition dia sama. Okay, kita cover sekali je. Heat change when 1 mole of a compound is formed. Bila sebut is formed, the species that you need to keep as 1 mole will be on the left hand side of the reactions or on the right hand side.
Right.
Right, sebab produk. Okay, maksudnya kita keepkan produk sebagai 1 mole. And baca juga from its elements in their most stable state. You want to keep the 1 mole of substance of the product, but then the product will be formed from their most stable state. Okay, apa maksud element in their most stable state? Contoh macam carbon adalah solid kan?
Yes.
Okay, dia stable as on the carbon in solid state, tu maksud dia. Bukan 2C, bukan C2. C sahaja in solid state. Itu maksud elements in their most stable state. Kalau kita tengok O pula, oxygen, dia paling stabil sebagai O sahaja ke O2?
O2.
O2. Jadi awak kena initiate the species as O2. Itu maksud elements in their most stable state. O2 in gaseous state. So, kalau kita guna contoh ni, we want to form water molecule kan?
Yes.
Yes, we need to keep the water molecule on the right hand side as 1 mole, and then this water molecule is composed of hydrogen and also oxygen. Hydrogen, the most stable state dia sebagai gas, sebagai diatomic molecules, right?
Yes.
So we have H2 to start with, and then for oxygen, diorang pun sepatutnya as diatomic molecules. So sebab tu kita ada O2. But in your product yang kita kena keep sebagai 1 mole, you need only H2O. 2H, 1O. Is it?
Yes.
Kalau kita nak keepkan 1 mole of water molecule, apa yang akan terjadi pada reactant side? Awak kena buatlah apa saja awak boleh buat asalkan water tu tak kacau dari mole lain, 1 mole. So kalau kita tengok H2 yang as stable state dia tadi, kita compare dengan produk, ada 2H kan?
Yeah.
Ya, so dah tak perlu nak balance dia, betul tak? Boleh keep je H2 tu sebagai dia sahaja.
Betul.
Okay, but then for oxygen gas, we know they come as O2 yang the most stable state. But then on your right hand side, in your water molecules that you want to keep as 1 mole, you require only 1 oxygen. So at the moment you have 2 oxygen, but you want only 1 oxygen. What should you do?
Half it.
Okay, halfkan O2 tu supaya kita nak keepkan 1 saja O. So, keepkan siapa yang 1 mole, everything else tu awak buatlah apa pun asalkan dia balance. Itu maksudnya.
Okay, Miss.
Okay. So, untuk standard of enthalpy of formation maksud yang sama, tapi notice that your enthalpy of formations only, you ada delta HF sahaja, but then when you have standard enthalpy formations, you have symbol of delta H not F. That note yang kosong ke atas H tu, yang subscript atas tu, kita panggil dia sebagai standard conditions. Awak kena hati-hati. Kadang-kadang soalan dia bagi awak simbol, maksudnya dia buat maksud apa. Sebab standard enthalpy of formations ni dia ada bawa benda yang lain sikit. Selain daripada definitions yang sama, okay, standard enthalpy of formations of any element in its most stable state form is 0. Okay, apa yang maksud 0 ni? Boleh ke Miss kata energy tapi 0? Boleh. Sebab dia paling stabil. Bila paling stabil, perlu ke dia bother dia nak release or absorb heat kalau dia dah stabil? Kalau dia sorang-sorang
Tak
dia?
perlu.
Ya, dah tak perlu dah. Sebab tu make sense dia. Tetapi, this zero delta H belongs to only standard enthalpy of formation. Formations of that particular element. Okay. So, for example, kalau contoh dalam awak punya thermodynamic equations, you ada carbon, you ada H2O, you ada NH3, something like that. Dia bagi NH3, dia bagi awak H2O. But then untuk carbon dia tak bagi. Tapi information dia bagi tentang NH3 and H2O adalah standard enthalpy formations. So, you boleh assume yang the carbon at the moment in solid state adalah the most stable. So, we can assume that the standard enthalpy of formations kalau dia tak bagi adalah zero. Okay ke? So contoh yang kita tengok dalam ni, contoh dia tak bagi tahu value dia. Tapi kita tengah guna tentang standard enthalpy. Kita somehow perlukan that value sebab nanti kita akan belajar in 2.3 yang awak kena cancel out the nak dapatkan targeted equations tu. Jadi sebab tu kita perlu tahu yang dia ni adalah zero. We know this Cl2, dia paling stabil dalam diatomic molecules and gaseous states. If they don't give you the value, then we can assume their value is zero. If needed lah, yang diperlukan guna dalam soalan. Kalau tak perlulah define dia as zero. Carbon, graphite ni adalah in solid state lah. Okay, jadi carbon paling stabil dia as just carbon and in solid state, we can assume they got delta H of zero. Boleh beza? Enthalpy of formation dengan standard enthalpy formation. Dia ada sedikit perbezaan pada value yang tak diberi. Nantilah, saya rasa awak tak nampak sangat sekarang. Nanti tengok soalan, bila nak apply in 2.3 baru awak nampak. Jadi tak apalah, tapi saya nak awak hafal dah siap-siap definitions ni and practice. Practice buat sendiri. Ambil je any reactions, try to buat. Okay?
Okay.
Okay, Miss.
So now the last one untuk heat change, positive and or negative, kita tak tahu lagi value dia. Enthalpy of solution. So what is meant by this enthalpy of solutions? If we look at the example, we have KCl. So this KCl is your, let's say you have salt, okay? KCl salt in solid state. Once dia undergo dia cakap enthalpy of solution is 1 mole of substance dissolved in solvent water lah to form an infinite dilute solutions. Kita tahu KCl masuk dalam air, tak boleh tunjuk pun tak apa, tambah H2O. Dari solid state, once dia hydrated, dia bukan hydrated lah, dia dah dissolve in water, dia akan jadi aqueous kan?
Yes.
So dia akan jadi ion lah kat situ. Daripada KCl, kita pecahkan dia jadi K plus dengan Cl minus, but now in aqueous state. Sebab by definition, dia form solution. Solution in aqueous lah, betul tak?
Betul.
So that's why you have aqueous instead of solid. Saya kena tekankan sebab akan ada orang buat solid jadi gas. Itu bukan definition solution. Solutions means you have, let's say, mesti solid lah. Sebab dia nak dissolve, solid must become aqueous state. Okay, and you notice that the enthalpy given is positive. Can they also be negative? Kalau soalan bagi negatif, boleh tak kita kata dia pun enthalpy of solution?
Boleh.
Boleh, sebab?
Either negative
Either
or
positive.
positive.
Yeah, because heat change indicates you can have either positive or negative signs of delta H. Okay, that's it for heat change. And last one, we have heat absorbed. Heat absorbed means you have positive delta H. So if we look at the example, half Cl2 to become Cl, both in gaseous state. Sodium solid to become sodium gas. So now, kenapa dia daripada gas boleh jadi gas juga, sodium jadi gas. Okay, kita tengok dia punya definitions. Heat absorb indicates positive sign of delta H. Okay, good. When 1 mole of gaseous atom is formed from its element. So bila kata is formed, mestilah yang 1 mole tu yang belah kanan. And dia nak 1 mole tu dalam gaseous state sahaja. Daripada gaseous state, mana dia datang benda tu? Daripada elemen dia sendiri. Jadi kalau elemen dia memang sedia ada gas, kalau atomizations pun produk dia jadi gas lah. Kalau awak punya asal elemen paling stable dalam liquid, once dia undergo atomizations, dia akan jadi gas lah. Faham tak itu?
Faham.
Kalau solid, bila dia undergo atomizations, dia jadi gas lah. Tetapi gas yang kita dapat tu dalam ion ke dalam atom sahaja?
Atom.
Atom sahaja, dia tak akan jadi ion lagi. Okay, so kalau awak tengok ni, kalau Cl, kita nak keep Cl sahaja, tapi Cl paling stabil as Cl2. So we start with Cl2 to become Cl, bukan kita nak bagi Cl yang jadi darab 2. Kita kena make sure Cl on the right yang be the 1 mole, and then the Cl2 yang kita kena modify. So kita akan halfkan the Cl2. As for sodium, initially we know sodium is in solid state, only 1 mole. Once they undergo atomizations, you also formed 1 mole of Na, but now in gaseous state. Clear?
Ya, Miss.
Okay, clear. So habis untuk 2.1.